Good morning, everyone. Oh boy, voice cracked. Might be a rough one today, folks. We'll see. Just got to clean up this absolute mess. And then we can get going on the input stage. Here's the stir. I guess you guys missed it a lot because of the reflection. That's okay. There'll be another one later, I'm sure of it. How's everyone doing today? Hopefully you all are good. Gotta start cleaning up here. So let's grab one of these little boxes that either the dial or the movement shipped in. That's the dial. And we will safely store the links in them. I keep all the links from all my watches in case I gain a lot of weight or I want to give them away or whatever. Or probably more likely than that, I encounter someone that needs extra links. So let's see, there should be at least 3. There's 3, but there might be one more. Did I remove 3 or 4? Does anybody remember? And we'll put our lock or our link screws back in. Just easier to store them like that. This one. So while cleaning, we'll probably find another one, I'm assuming. There we go. There are the links, and we'll put those in there. If you have a real watch, like a Rolex, some of those links are made out of precious materials, and people don't know that. So if you find like a link on the ground from like a Rolex or something, or like in a box, like storage or whatever. Some of those links are like 14 karat gold. Not gonna find any of those links here, but if you, you'd be surprised what people lose. All right, and we've got the NH35 service crown. Jesus Christ, it scared me. Build plate fell off. Like so. Probably put this in the box with the links. There we go. And I need to make myself a little traveling case for like just like a case for all of my watch tools. Probably end up 3D printing something. So I keep all my watch tools together. There's always like weird things going on. Like sometimes my dad would need help with his watch, like replacing the band or something, or taking links in or out. I always like to be the guy with the tools. I always have all the tools on hand for pretty much every job I get into. All right, so this movement holder, I'll just put it back in the box. So the pillow The blue tack. Here's another one of these little boxes. Well, every time I try to do this, it just rips and tears. Like so. And I've got these fancy tweezers that I need to find a home for. Jesus Christ. Do have tweezer storage, but it's a little sketchy, and I don't want the ceramic ones to fall, because if they fall they could chip the ends of them. Oh yeah, watch your eyes. I'm going to turn on the studio lights. Like so, and like so. I'm going to pop that over here. There we go. Should be hanging up. They need to be in a better spot, but it is what it is. Found another part that can be stored in here. Like so, and a little screwdriver. Don't need the box for the pillow. Casing cushion, holded by a nickeled brass ring. I don't think so, bud. That is not brass. That is as plastic as it gets. Definitely not brass. Definitely plastic. A little cloth. Can throw away all this stuff. There we go. Box. I need a little container for Q-tips. Oh, and these are the watch hand pushers. Oh, gonna put them in the finger cots. And the finger cots themselves. All right, so I've got this for watch tools, and I've got this for watch tools. So put these away somewhere. It's really hard to close this case. Again, I need some sort of solution. All right, and I'll put these somewhere where hopefully I'll find them when the time comes to use them again. Oh, I guess I could have stored this with them too. This is a to align the stickers on a dial. Okay, a little piece of emery board, little opener, magnifying glass. We're almost back to normal. Oh, forgot my little air duster. Just gonna check something real quick. Oh, that's interesting. I accidentally put the stream to unlisted. That is interesting. Never done that before. All right, well, I guess the first 11 minutes of stream is just me talking to myself. I was wondering what was going on. It's a little awkward. Don't know how it ended up unlisted. Good morning, PC Board Repair. Do you have notifications on? Because apparently I scheduled this stream as an unlisted stream. I've been streaming for 11 minutes to myself. Very strange. Yes, notifications on. Aha, notification gang. Unite. All right, we're almost done cleaning up here. Yeah, it's because this stream was unlisted. Oh boy. What an idiot. Okay, I'm gonna disconnect from here. Disconnect from here. The 3D printer is whirring away this morning. Yeah, it was even worse, ITT. I was unlisted. You're in your studio editing titles and descriptions. I hate that part. It's my least favorite. Because I feel like the editing part is such a long process, and then you make the thumbnail, that's a long process, and then you still have to do the thumbnail, the title and the description, and if they're bad, your video fails, and yeah, pain in the frickin' butt. $1,200 videos. What? Do you really have 1,200 videos? PC board repair. One 1.1K. Jesus Christ. You have so many videos. Is this you? Or is this just AI? 2008. Wow, yeah, you've been doing it for a while. Soldering Basics, 1 million views. We both have a video with 1 million views. Multimeter Basics, I've got one too. Yes, that's you. Oh, neat. Handsome man. Lots of AI has entered your process lately, huh? Watch first 15 seconds of your soldering video.
In this video, I'm going to demonstrate how to solder. And these are the tools I'm going to use.
What about it? Just because it's old? 16 years ago? This is the 3D printer whirring away, by the way. Yeah, very old. That's good. I mean, hey. Oops. Multimeter. This is my video.
Hey everyone, welcome back.
500,000 views. It's getting there. And then 1.3 million on this one. You still have that iron. Very nice. This was my breakaway star for a while, but now, yeah. And I've sold so many Elegoo kits on this video. Cool beans. Yeah, I saw you commented something. I saw that. I gave you a little heart. Okay. So, I would very much like to modify this design to sort of like be amplified so we can get a smaller voltage here. Now, the problem is, I was pondering on this. The problem is the PC817 has an LED. We can't get away from that. We have to light this LED. Used to record videos and just upload no description. Yeah, I don't blame you. So because we have an LED and we need a series resistor, we probably won't be able to get a lot out of the other end. So here's what we're going to do. Let's see what the minimum voltage is. My normal workbench is when the box falls on me. I mean, something did fall and hit my head. What was it? It freaking hurt. I remember that. What we're going to do is we're going to test. Yeah, we're going to test how much voltage it takes to power on the LED. So let's get this set up. So we need 3.3 volts here. So we can go on to volts there, and then this guy, we are going to just grab the edge here, and then we're going to drop the current, going to limit the current to 20 milliamps, 0.02. You know, we're going to drop the current even. No, we're fine. We're fine. And voltage, I'm going to set that to 2. 2 volts. All right, if I power on channel 2, so now there's 3.3 volts here. I won't spill it. We're good. You just watched the 11 minutes? Nice. Okay, now 2 volts. We're at 20 milliamps, and I'm just going to drop channel 1 volts. So I'm at 1.1. 1 volt is not enough. We've got half a volt here. So let's go up. We've got 0.6. This is 1.01. So 1.01 volts. 1.02. 1.03 volts on the input here. What's the threshold we're looking for? 1.65. Okay, so here we go. We get enough voltage on the output to turn on an LED, or to give our MCP a high value at 1.040. But here is what I'm thinking. The trigger is 1.65 if we want to be sure that it'll turn on. 1.65 because the MCP has like a plus minus variance. So, that being said, if I swap this over to here, now we have a voltage drop. So let's see if we can get this through 1.3, 1.4, 1.5. Yeah, so I won't be able to. 1.8. But you see, I wonder if this 1.7, 1.8, if we could use this to get a transistor to turn on. Let's see if we can do this without the series resistor. Just curious. We do need the diode because of reverse protection. We're going to deal with the series resistor in a moment. So we got 2.4 on the output at 1.6 volts. So 1.6 is really the limit. Here's 1.5, 1.51, 1.52, 1.53, 1.54, 1.55, 1.56, 1.57. So at this point, 1.55, 1.56, we're starting to get to the point where we can light, like we can definitely have a transistor amplify the output signal. I think the problem lies in the fact that we have a diode and an LED. So there's really nothing we can do unless we make a full different power supply or we drop the PC817. Used to have coffee at your bench until a fellow tech put MEK in your coffee. What's MEK? What's MEK? So the deal is the combination voltage drop of the diode, which is non-negotiable, and the PC817, which is not negotiable, is too much. We would need to amplify the in signal if we wanted to be sure. And if we amplify the in signal, that means we need a completely separate power supply, like an isolated power supply, to deal with the amplification. And then with the PC817, it's not possible. Methyl ethyl ketone or something. Oh, great. So no matter what we do here on the PC817's output, we're not going to be able to feed the input with more unless we have an isolated power supply. It's not going to happen. I like the opto. I don't want to get rid of the opto. I think we're just going to have to deal with the fact that it has a 2.21 volt minimum threshold. So the next thing to do is going to be to test, instead of one 2K ohm resistor. No, PC817 does not have a high enough reverse current protection. PC817 data sheet. Um, 6 volts. That's it. Whereas my diode, which is a, let me grab the part number, 1N4148. I think it's 100 volts. 1N4148. 100 volts. Peak and 75 volts normally. No, definitely 7 volts. It's really not made for reverse voltage protection. So yeah, I think it's a feature of it being an infrared LED. So yeah, our best bet now is to see if we can drop the skin temperature by using 2 1K ohm resistors. That's going to significantly increase the price of our setup and the board space of our setup, but it is what it is. So brown, brown. Oh, it's the other way around. Brown, black, black. So it's 1, 0, 0, and then 1, 0 with a brown, and then brown is the tolerance. So this is a 1K. And I will have to order more of these. I don't have that many of them. This is the 2K. This is the story of a girl. Cried a river and drowned the whole world. I don't want to get copyright stricken because of my accurate singing. Though she looks so good in photographs, I absolutely love her when she smiles. Where did I take the other one from? Here. Alrighty, onwards and upwards. And my little signal diode. You know what? I could probably drop to half-watt resistors too. Okay, so we got 1.5 volts on the input. So our old, here, let me bring in, really should have done this differently. Okay, hang on. Hang on. Wait a minute. Everything is current limited, so even if I short something by accident, it won't be a big deal. Okay, so let's hit that 2.21 volt. 2.21 volt minimum. So there we go. And can we drop lower? For some reason we can go 2.2 volts today. So 2.2 volts minimum. And we have NAFOL 0 milliamps, 0 milliwatt. Okay, we're going to grab our thermal camera. Thermal camera is not going to show us anything at this voltage. It can be NAFOL. It's weird when you first put the battery in, you got to give it a moment and then you can turn it on. It's like it has to do some booting or something. Where are we? There's like literally nothing to see here. Okay. So we got 1.683 on the output. Let's go up to our next target, which will be 5 volts. Here's 5 volts. And then you've got 5 volts. That gives us, oh, it's just fluctuating between 0 and, 1 and 2 milliamps. So 0.001. Oh, let's go 2. Let's go the higher value. And then 0.010 watts. I'm going to give that a moment to heat up, but it's going to be naff all. The only heat I see is the reflection on the clip. Let's go up to 12 volts. Good morning, Lockwatcher. The first 11 minutes of this stream was on a unlisted stream for whatever reason. Okay, so 12 volts input gives us 5 milliamps. And 60 milliwatts. And now we are going to be generating some heat, 60 milliwatts, but not a lot. Yeah, the resistors are on now. 28, 29 degrees Celsius, very respectable. But I think instead of these 1 watt resistors, we're probably going to use like, I don't know, we're going to use like a bunch of parallel resistors. Keep skin temperatures low, and at the same time we can do SMD resistors. So they're going to be very cheap. Like we could buy 0805. While this heats up, let's check the price for some 0805 resistors. If we need to buy like 1,000 of them. Let's say it's going to be like 1. $805. Probably go smaller. Yeah, so it's like $5. Nice. Coffee's always good. And I think like 0603. Same price. So you can put like 5 of them in parallel. I'm an order of magnitude out. Did I miss one? Oh, here. Okay. Still order of magnitude out. So yeah, if I put 10k ohm resistors in parallel, we get 1,000 ohms, which is what we need, 1k-ish. And then each of them will dissipate 1/10 of the power. So we can probably organize our way to something like that. I don't know if my batteries are dying or if my Fluke just did auto off. So let's see. They're already 30 degrees. So I got 31.6. All right, let's crank her up to 24. So now we've got 24 volts. We've got 11 milliamps. And we have quarter watt. 264 watts. And now these will be cooking, and we're probably going to soar past our 45 degree mark. We're at 42 already. So I'll need at least 3 resistors together. So what I can do is I can do 4 500 ohm resistors, because right now there's a quarter watt dissipation. So I can do 4 in series or in parallel. Or like 2 in parallel, 2 in series type thing. We're going to try it today. We're going to try to do 2k ohm. I have 500 ohm resistors, or close enough. Like, I'll put 470 and see if we end up. Yeah, we're too high still. We're very close though. 47.3 degrees. Let's see, if we use 470 ohm resistors, we might be very close. So 470 times 4 plus 470. I'm gonna go a little bit higher up if we go 5. Vala the coonhound, wife's dog, got in a fight with a groundhog. Yikes. I'm glad your dogs are okay. $800 plus vet bill. So we'll have to either do 1880 or 2350 for resistors if we use 470 ohm. We could buy 500 ohm. What am I looking for? Looking for my... I forgot where I put my Open Robotics platform. Oh, here we go. Lab notes. That's not it. Oh my God. Here we go. From single resistor. All right, so next test 2 times 1K are in series. Tested thermals on 2KR resistor are in series. I should probably just write these in now. Yeah, let's do it. Minimum input voltage. Whoops, voltage. Voltage to reach 1.65 volt threshold. 2.11 volts. Volts at 2.11 volts. Unreadable current and power supply. Testing at 5 volts. Studio says you're getting 92.3% new viewers. That's pretty good. You got 10. Oh yeah, that was a mistake. 1 milliamp, 50 milliwatts. 0.01 amp, 0.05 watts. Room temp resistor. Testing at 12 volts. We got 5 milliamps, 60 milliwatts. And 0.06 watts. 34C resistor. I need to write this all down because or else, because now I can erase my whiteboard at 24 volts, 10 milliamps, 0.24 watts, 0 amps, 24 watts, and 63.7 C. 3.7 C resistor. Too hot. Okay. Minimum input voltage. Jesus Christ. Voltage to reach 1.65 volts threshold. 2.1. Is it 2.1? Oh, 2.2. It was a little bit worse. 0.2 volts. At 2.2 volts. Unreadable current and power on power supply. Testing at 5 volts. We got 2 milliamps, 10 milliwatts. 2 amps, 0 watts. And noise of power supply. Room temp resistor. Testing at 12 volts. We got 5 milliamps, 60 milliwatts. Watts. And then our resistors were at 31.6 C, which is a drop, but not a lot of a drop. 31.6 C. Resistors. Testing at 24 volts. 0 point. We've got 11 milliamps, 0.11 amp, and 0 point. 264 watt, and then temperature on the resistors. When you worked for Canon, they would make a whiteboard the size of a classroom chalkboard. You can write on it with marker and then hit copy. Scan the image on the whiteboard, print it on a piece of paper. That is really cool. Okay. And what do we have for temp? Oh, we're so close. 49. Why is it cooling down? $48.8. That is so close. That is so close. That is so damn close to my target. I'm looking for 45 degrees C. So in principle, should be able to touch this without getting burned. Yeah, no problem. I am so close. I might be close enough. I might very well be close enough. Here, let me check something. If I grab, let's see what my common resistor sizes are. Yeah, I have 470 ohm resistors. So if we put 4 of these in series, what's this for? This is for the Open Robotics platform, the input stage. Let me, So here it is in chat. I'm going to pin it. So the quick pitch, the elevator pitch is down here. Project has a goal of simplifying the controlling of electrical, mechanical, and electronic components commonly used in robotics and electronics projects. So the point is it will allow users to set up simple input stages to accept wide ranges of input types and voltages, have them act upon wide ranges of output types and voltages. So essentially what it's going to do is the end goal is you're going to have a board, one side inputs, one side outputs. You connect your inputs to whatever. You connect your outputs to whatever. So let's say, for example, you have like a battery and a switch on the input. On the output, you have a motor. And you can, essentially, you will just be able to set up this input controls that output, and speed is whatever. So that's the goal. So I'm just trying to make a safe input side where you can go up to 24 volts. In fact, I'd rather go up to 48 volts. So it doesn't get too hot, so students or beginners don't burn themselves. And honestly, we are so close. Went up to 49 now. We are so close. So I think what I'm going to do is I'm going to do up let me save my document here. Save, there we go. So I'm going to save my document, and what I'm going to do is I'm going to erase all this. We are going to put 4 470 ohm resistors in series. Yeah, a Zener could be fine. That's another, we'll deal with that another time. But you are right. Let me put that in the notes. To handle higher voltages if a Zener dropper is used. It is a good point. Thank you for that. Nice. Designed and built a multimeter. Very cool. All right, let's just use the cheapest shit we can. So we're just going to go series across here. You know what? This is a visual medium. Sometimes I forget. So let me build up the height for you guys. These guys. There we go. And the little soldering pad. Turn on the soldering iron. I, Ron Butterfly, rock and or roll. the Gen Z are like, what are you talking about? I don't even know if there is any Gen Zs in here. Any Gen Z in here? Good school, went to RCC, made a meter, amplifier, amp. Very nice. So there's four 470 ohm resistorbs. Let's do a quick tack. What is Gen Z? I don't know their official age, but kids born in the 2000s. Zoom in, damn you. There we go. These boards, yes, they are crap. But I have them, so I'm going to use them until they're all gone. So this is a little pain in the ass because I don't know if I'll be able to properly get it situated. But we'll try nonetheless. There we go. That's one. They have to be sitting so deep so that they're not bridged. I've been putting a lot of thought, guys, into going back to school for engineering. Electronics engineering. And if I get a track, it would be like into robotics. Problem is time and money. Money is going to be a little less tight for the next 4 months. Possibly even less tight after that. We'll have to see. But time is always going to be a constraint. Arguably, why would I need to go to school? If I do get hired full-time at my dream job, we'll see. But I want to learn the base principles. And once you get the diploma, nobody can take it away from you. You got it for life. There are very, very few engineering courses online. You can take, so I looked into this. There are like a couple of courses that you can do online. but you have to be in person in university for the vast majority of it, like 9/10. I have a Max Steel. I'm not sure what that means. Build a lot of robot things. I have a Hero. What's a Hero? Heathkit robot. Oh, okay. My shop here is well equipped, except for a CNC or a mill. It's pretty well equipped to do robotics. You can make plastic robots. Did you see the CNC? No. I think I did an overview. I didn't go in and take a good look. I've needless to say, I've had a lot on my mind lately. Whenever I think about the job that I'm starting in 2 days now, I get incredible anxiety. But it is what it is. Like, I have to, it's something I just have to do. All right, I need resistor leads. And I kind of want to steal them from these. No, these 2K resistors. But rest assured, if you have a CNC, I am beyond envious. So if it makes you feel better that I'm yellow with envy, green with envy. What color is envy again? I don't remember. Anyways, if it makes you feel better, I am envious. I haven't even seen it and I'm envious. 4x4 CNC with a huge air-cooled spindle. I actually want a mill more than a just standard CNC. I would like to, I don't care about like big things, I'd like to build small things. So I would very much like a Milo mill. Mach 3 CNC, just edited all that yesterday. No one had seen the videos. Very envious. Very envious. Like one of those as well. Yeah, the Milo. How do I do this without burning my little fingies? I know, I need to suspend it like this. That's what I need to do. Unfortunately, my 1, 2, 3 blocks are right now are pen holders. You know what? Blue tack makes a bad smell when it heats up. I'm not such a fan. Did I yeet my resistor leg into the ether? Oh, it's stuck to the block. So you know what? Maybe that'll be my first huge purchase if I do get full-time at this new job. Maybe I will get a Milo mill kit from Sparta. Okay. Here's blue tack. Would very much like a mill, but I think right now, I think the big problem right now is I have a lot of shit to learn for the new job. Like, I know the basics, but this is a prototyping firm. They are not going to be impressed by basics. They've got people who know the basics. There we go. That's got it. Here the 3D printer is making more noise now, so I think it's done the surface of what it was printing. Now it's printing the walls, I'm sure of it. There we go. We've got our through-hole surface mount resistor. 3 foot tall. That's super cool. There's 2 electronic all plus software. A 3018 and the huge Mach 3 CNC. If you Google Maps Street View Franz Butcher Shop in Peterborough, the sign is built on the building I cut on it. That's really cool. That is very cool. See, I want to make aluminum parts for robotics in-house here. Gears and stuff would be nice, but gears are very, very difficult to cut on a hobby CNC. Like the end mills that you have to use are absolutely tiny. Most like gear train parts are like hobbed or cut in one giant one giant bar on a lathe and then part it off. But there's no way I have room for a lathe and a CNC. It's one or the other. And those like Hobbycraft lathes that you can convert to CNC. Sorry, I just sneezed there. They're not precise enough. To cut letters into 4-inch, 6-inch, 8-inch cedar posts. Most of your stuff you never see, yeah, making the props for sure. Hi, Franco. Some idiot, we're not going to name any names, but some idiot set the stream today to unlisted. And I don't want to get into like who did what for why and whatever. We don't have to play the blame game. You know, I think he meant well. But because of the screw up of the person I won't name, I streamed the first 11 minutes to myself. So that was lots of fun. Okay. So here's the run with 4 times 470 ohm resistors, 0805 package. Father's house, we have a 30-inch lathe, V-guides. Oh, I'm so envious. But then again, like I can't do everything, right? Like I've got 3D printers here. Like I've got stuff. I probably will end up building a Milo mill at some point, but you know, like I've got a lot of stuff already. I'm honestly at the point now where, practically speaking, I would need to build a very large shed, or I would need to move before I could fit like machining equipment down here. Or take up more of the basement. Move the laundry machine somewhere else, I guess. Okay, so here it is, testing 4 170 ohm resistors, 470 ohm resistors in series. Now it's going to be a little hard to get the temperature because they are so shiny. If I had like a matte paint, I could put that on. Actually, you know what? I think I might have a matte paint that I could just paint on him. Let me see here. I might actually have exactly what I... Oh no, I don't think I do. Never mind. I have a paint marker. Will that work? Just trying to dull the reflections of the solder. How's it going, Anant? Check the pinned comment. We are attempting to build the input stage of that project. There we go, dabbing some white paint. See if we dulled most reflections. We did. That works. Okay. So, let's put away the paint marker before I write on my whiteboard with paint marker. So here would be the test for 4x 470 resistors, 0805. So this will be similar for 0603, but we'll have to test them when they come in. I'm going to be pausing for coffee soon, not right now. Okay, so our minimum voltage. Wait, we need 1.65, didn't we say? So I'm just cranking up till we get 1.65. Okay, 1.652, that's 2.164, 2.164, 2.165 volts, I should write because that's the actual measured output. 65 volt minimum. Okay, it's unreadable for everything else, so now let's crank that back down to all zeros. Here, just go 5 volts, enter. All right, so at 5 volts, we've got 0.002 amps, 0.010 watts. And temperature will be room temperature, I presume. Yeah, we've got nothing here. Room temperature. Okay. Oops. Then I'm going to go up to 12 volts. There's 12 volts on the input. Now we're going to have to give a moment. The resistors are heating up. Let's give them a moment here. They're already at 30 though. I don't know if that's going to be a good sign. I'll give them a few minutes to warm up. All right, here it goes. Need to buy more paint markers. I wonder, is paint markers an Amazon thing? Because usually Amazon's a bit of a pain in the butt because they don't like shipping hazardous stuff. Oh yeah, they've got paint marker. We got lots of them. Good. Probably order some paint markers. If you guys want to see the progress on the 3D print. So it's got an hour and 28 left, so it'll probably be done right before we're done stream. Staples. Yeah, I'll check out Staples too. Usually local retailers are much more expensive. Well, the problem with the paint markers, Franco, is that they have a solvent inside. So this one is from Princess Auto. So they have a solvent inside, so they're kind of like difficult to ship legally. All right, so 32.9 C, a little bit warm. This is at 12 volts. Oh, I didn't take any of the readings. 12 volts, 0.005 amps, 0.060 watts, and then whatever that was. .2 C. And let's crank it up now. 24 volts. So 24 volts is the target because that's PLC territory. 0.011 amps. And we've got 0.264 watts, so just over a quarter watt. So these might be 1/8 watt resistors, not 100% sure. And we'll check the temp on that. I'm going to write down these temps while we let that heat up. So 2.165 volt minimum. Two 2.165. Testing 4 times 170R0805 resistors in series. We got 2.165 volts minimum, 2.165 volts minimum at 2.165 volts. Okay, testing it. These are pretty much the same. Testing at, this was, is that the same? Yeah, same. 5 and 6, same. And 11 and 264. So this is exactly the same. And this one, the temperature was, oh my God, I can't read. 33.2, a little bit worse. And now we're gonna check at 24 volts. Let's see. Womp womp. 58 point 58 point something. Let me just check. 58.4. Is it not working? Oh, 57.1. That's a shame. It's hotter. I was like, what the hell? What is going on here? Why is this stuck to this? Turns out this has magnets in it. Interesting. So sorry, what was that again? 57.1. It's worse. 57.1 C. So we need at least 5 resistors in series. Because a PC board repair, the reason is a PLC has a minimum voltage of 24 as well. I want lower minimums. What did I say? 51. I don't remember. $57.1C. 1C on resistors. Oh 0805 resistors will require at least 5 in series. But we can just use a Zener dropper, right? We could do that too. But I mean, the current has to go somewhere. There's no ifs, ands, or buts about it. So 5 resistors starts to get a lot. If we want to get our like 2K-ish, 2K-ish ohms, starts to get a lot. But this works for testing for now. So now what we could do is we could link both of these together. So we can actually check that the microcontroller is reading inputs. Which we should be able to. But I think right now is coffee break time. I just need to find, I don't know where my sign went. I need to like tether it somewhere. Like pull it down and then take it back up. Where'd my sign go? Can I trust you guys to every 30 seconds write, Dan is gone for coffee, he'll be right back? I brought the previous breadboard in. I've got like hundreds of breadboards. And by hundreds, I mean actually probably about 20. Yes. You're correct, Franco. More resistors, but I'm just thinking as like a, yeah, the MCP. Shana. This is just the input stage will be connected to each MCP input. What did I want to do? Yeah, my sign. Oh, I'm an idiot. I've got a giant frickin' sign right here. Okay. Can't trust this. No, I know. I know I can't. That's okay. You guys are here for entertainment. See if I can put this shit away. Let's stick to this. No, this is not metal. This was a cheapie. All right. I'm going to be right back. I'm back. Guess who Bazak? Back on the block. With the foe, 'cause the streets is all I know. Yep. Jesus. Okay, we're good. This whiteboard, nice desktop size, is from Dollarama. And I'll give you the creamer swirl. I'll try to do it over here. Oh, look at that beauty. I do need to clean the cup. Okay, so we can turn these two channels off. So now we just need to combine these two facets together. The magnet erases the screen. Yeah. Oh, there's a hair in my soup. I got no one to blame but me. All right. So let's combine these two circuits. We've got everything noted. Just make sure I went Control S on it. Save that stuff. Oh yeah, I need to check one more thing before we proceed. I have to see what time Claude usage resets. Because it resets today. 7 hours, 14 minutes. Okay, let me start VS Code and have it do the next step. Continue. There we go. Trying to make the most use out of my Claude subscription. Here would be from the same idiot that put the stream on private. Yeah. Okay, good. So let me erase this as well. We saved everything. What's the oh no, you did it? Oh, the stream. Give me a second. I gotta sneeze again. Turns out I'm allergic to working on circuits. All right. So I have not yet built a wiring diagram with the MCP included. But it is what it is. So with the MCP, we do need a micro, so we'll have to keep doing the microcontroller stuff. So let's see here. Let's shift all the input stage stuff down. It's a pretty simple circuit put back together. So move this down almost as low as it'll go. Here, so you guys can see a little bit better. A light bulb will work as well as a variable load in series. Yeah. Yeah, I can see that working. So here is our load ground. You know what? We're going to switch back to the 1K ohm. For no other reason than it looks neater. It's also more representative. It's closer to what we'll expect to see. Like so, and then we'll put the diode like so, making sure it is the same direction as it's supposed to be. That looks good. And then this is our output to the MCP, which will be all the way over there. So output to the MCP. We want the output to ground like this, and then output to ground like this. This is a resistor capacitor network to ground for debouncing. And then this is our MCP. Okay, so let's just unplug all of this. We'll position our things and we'll get ready to go. So we're going to switch. We do need our pull-ups. Let's not forget our pull-up resistors. So we'll put the micro up at the very top. That in our MCP down below that. There we go. That's good. We know all the channels are working on this. That's good. Oh, baby. Nectar of the gods, I tell you. A little bit of a good stretch. Okay, so from now on, the 3.3 volts for the MCP logic input actually will come from the RP2040 in the final. Are you just detecting 5 volts, 24 volts? I'd use a feeder, a resistor feeding a LM78L05 reg. You can use digital that way through the PC817, no real heat from your e-bike controller design days. So the reason why I wouldn't do it like that is that you need a whole other, like I have thought of that, but I think this is better. I think this is better. And anyways, I've got other ideas for the future. We'll just keep that in mind. So I'll just tie this negative to negative. So yeah, the 3.3 volt comes from the RP2040 zeros regulator for the input stage for the MCP. The MCP will also be powered by that same 3.3 volt regulator. In the future, though, there will be a dedicated like a AMS 1117 3.3 volt regulator. So we're going to do it like that. I think there's a problem with very quick signals with using a regulator. I did look into it and I don't remember what the result was. This is our hand soldered adapter board. See that with pin 5 has a little bit of exposed track. That's okay. Okay, so let's do the I2C lines. I usually use orange and yellow for I squared C. So I usually have pairs of them kicking around everywhere. Let me just grab them out of here. Let's see what my lab notes notebook is saying. Okay, so 4 and 5 is SDA SCL. So 4 and 5. There we go. So 0, 1, yeah, it's below 4 and 5. So SDA is yellow, and it needs to go to pin 13 of the MCP. And this one needs to go to pin 12. And I need to pull those up to 3.3. So we don't have the same problem. Low cost, non-isolated way, LM339 have the op amps trigger off voltage presence. Yeah. Yeah, I do want the isolation. There could be a lot of potential for boo-boos from non-electronics people, which are the types of people I'm targeting with this project. So there we go. So we got nice clean pull-ups now. There we go. So we're in good shape. And so, yeah, the reason why you need pull-ups on I squared C is the open drain nature of I squared C communications. Nothing on an I squared C bus can bring anything up. It can only pull down. So you need to pull it up. Why can't you use the internal pull-ups, you might be wondering? Because that would only work if your pin is configured to input. You wouldn't be able to drive I squared C with it unless you bit banged it. You can't use the hardware I squared C. Get a single dip package with 2 LM339s in it. I would use SMD parts, because don't forget, we're going to be a little bit limited by our PCBWay 10 by 10 module. If you get 8 or 16 of those circuits on the input and a lot of heat from 8 to 16, yes, of course. But the maximum we're going to get is 8. Because we need the same MCP, we'll be doing outputs as well. So very likely the MCP will be driving PC817s as output stages for full isolation as well. We'll see. I haven't designed the output stage yet. Just doing input for the moment. All right, so pins 1 through 8. These are our GPIOs, and then pins 18, or sorry, 28 through 21 are our other GPIOs. So it's actually well positioned here. It's all the top ones. We need to power this. So VDD. Oh, we need to tie pin 18 high. Definitely need to do that. We don't have to use, we can use a resistor, but we don't have to use one. So let's tie pin 18 to 3.3 because it's a not reset line. 18, tie it high. There we go, that one's tied high. 15 to 17 need to be tied low. So that's these three here. So we're just literally going to tie them low. So we get the default address. There we go, and one more. So they are now tied low. Okay. Pin 14 is not connected. That's fine, it's not connected. Pin 13 is SDA, 12 is SCK. That's your I2C communications. Pin 11 not connected. Pin 9 needs to be connected to VDD. Pin 9. We're gonna hop over pin 9 to 3.3, and then pin 7, or pin 8, sorry, is gonna hop over to the ground. Okay, that's good. And then that's it. So now we just need some RP2040 code. Two LM339s. You guys can. This is the way I'm doing mine. So you guys can do it however you'd like. This is the great part. My design is open source, so you can fork my design and do it however you want. Okay, so let's connect the output here to an input. So output of here to input of here, we're going to use pin 1, which I forgot which input that is. Yeah, fork. Forking a repo means that you create your own branch of it. Like you take what I built and you build on top of it. Open source, baby. All right, so let's get Qwen to work. .qwen.ai. Go back to this one. Okay. Keep all pin assignments the same, but scrap all the code. I need new code that will monitor, not sure which GPIO is pin 1. Pin 1 on the MCP, and on a low it will toggle pin 28 low, and on pin and on high it will toggle pin 28 high. Can you, yeah, whatever. I need the code for that, please. Thanks. Make Don't make any mistakes. You are live on YouTube. You don't understand? So you go here to my GitHub and you can choose to like branch this off and make your own project. So you can take everything that I made as a starting point and then you make your changes. So I don't really know how to fork someone else's repo. I think when you're signed in, you can do it, but yeah, get AI to guide you through it. This is getting there. Yeah, GitHub is an acquired taste. I am 100% with you. I think for normies, it shouldn't be used. Just my opinion. So, yeah. GPB 0 and GPA 7. Actually, rewind that. Can you map pin 2 input to pin 27 output and follow that logic for all the GPIO on the MCP so I can test them all sequentially. Yes, you are a normie. The gloves are off, my friend. But yeah, non-coders shouldn't need to go here. That's why I have my website. These are broken, that's okay. Articles. So here you go. You can come here. Here's my video. Here's the written example. Here is the code. You can literally copy and paste this code. Literally, copy and paste. You do not need to go to GitHub. But, case and GitHub, check out the GitHub for the case and the code. Here, bang. There's the GitHub if you need it. This is my jam. Here's the code. Here's the code. You can copy and paste the code. Do they use terms for everything? I have a website with your CNC videos on it. Nice. I think we need to own the means of production. So I have websites. I have a few websites. NRF 905. You can't just post that there without context. I don't know what you're talking about. Oh, I love Quen, but God, is that ever slow. by Qwen API. Oops, AIP. One million context length, nice. What's the cost? Let's go. $1.25 for 1 million tokens, and $3.75 for 1 million tokens output. $1 million tokens on the free quota. Is there like Qwen code? My God, look at this. Qwen is a Chinese AI made by Alibaba. And it is great because it's a lot less American biased. So it doesn't quite bias American content like Gemini and all the American ones do, especially Gemini. Gemini and ChatGPT are like the worst for American bias. Nothing exists outside of America, according to them. And the free tiers, like you just go chat.qwen.ai, they are way more generous than the free tiers of all the other AIs. The only thing I don't like, right, I'm using their state-of-the-art model here, Qwen 3.7 Plus. The only thing I don't like is it's so slow. It is indeed slow. Their state-of-the-art is Qwen 3.8. You can use that as well. So it takes it a long time, but like, it does a good job. So, yeah, me too. AliExpress, I've been using it since probably before that. Also, what Qwen is great at is you can download Qwen models, because they're open source, to use locally. If you have a good graphics card, I have a 5070 Ti with 16 gigs of RAM. I can run a Qwen Vision model pretty easily here. And it does a really good job. And this year, it's going to do my taxes for me. Obviously, I'm going to be double checking it. But the point is, the bulk import of all my screenshots of all my receipts, Qwen is going to do it for me locally, which is freaking awesome. And I'm even going to do multiple passes to make sure it's good. Thousands of devices, and anything that arrives broken, looks shabby, it gets returned. Yeah, I've never done a AliExpress return. I've only had like very few problems. There's a few times where stuff didn't show up at all. And so that was a pain in the butt. But very, very few times did I get anything that's like broken or whatever. We need an LED for our output. Or, you know what? We don't need an LED. We can use the DMM. So let's ground one lead. And let's grab white, because our other input is white. Phantom 3, nice. Only use eBay, only have one issue, full refund, they didn't want the device back. Very nice. Jesus Christ, Qwen is still going. Again, I do like that Qwen is free. The only thing is, there's not really a generous free tier for Coding Assistant. And the reason I like AI coding assistants more than like the ones you use in your browser, I mean, yeah, APIs are not available freely very well. And why I like APIs more is because APIs mean that you can have it generate files for you. So you don't have to like copy and paste it out of the browser window. You can just ask it to do it. It makes the file for you. I take it UPS store, all paid for. You get your money back within 24 hours. Nice. Very nice. Very nice. So yeah. Big fan of like coding models because they generate documentation for you. There is a way to connect your local LLM to like VS Code, but I've had very limited success. I need to buckle down and try again because there are lots of things that I use Claude for that, generally speaking, I can use a local model to do most of the work and then have Claude come in and fix it. Or improve it. Or whatever. I'm getting really impatient now. Quen is still going. It's in a endless loop. Told it to skip. No. Oh yeah, okay, excluded all those. It's good. It was stuck in a endless loop. Just scan a picture on your phone AliExpress app and print the label. Mostly it goes back to Markham, yeah. What? That's not what I want. I don't want it to self-test. I want it to monitor the input side. Physical pins 1 through 8. Wait, how many GPIO? 8, right? 1 through 8. And have it toggle the output side physical pins 21, 28 to 21 when they read a high. You thought about it too deeply. Jeez, Murphy. The underwear and shorts you're wearing right now are from AliExpress, bought back in 2016. For clothes, I'm mostly a Costco guy. Costco is like the sort of the fashion that people my age are wearing. So yeah, not quite. Excuse me. The price on AliExpress have definitely risen. You're 100% right about that. Let's see how long for the 3D print. Another 35 minutes. We're getting there. In case you're wondering what I'm printing these parts trays. So this is in that Galaxy Black Elegoo filament. There's a little bit of PVA glue on the bottom that I need to get rid of. But there's trays that fit inside here that interlock and stuff. So I'm printing all the base trays in one color, all the intermediate trays in another color. And I'm gonna start with 3. So they interlock, fit inside of each other like this. They interlock better if you have them the same orientation. So there we go. And then the inside trays fit in there. So, you know, when I'm working on stuff, I can put a bunch of parts, and then these things will stack in my shelves, and I can put labels on them. So I have a label maker. Yeah, look at the really nice filament. Has the Galaxy speckles. If you could see the shorts, everyone says, did you get those shorts? They have pockets, says surf on the leg. All the colors, black, red, orange. Very nice. Very, very nice. So a influencer marketing team have reached out to me about another 3D printer. It's not the company directly. I actually have to ask. Some of my friends have gotten sponsorships from this company, but I have to ask if they got it directly through the company or through a third party. Because I don't know if I want to do another 3D printer review. I've got so many 3D printers here. Mind you, I can take them apart for parts and build a milling machine out of them. But I don't know if I want to do another 3D printer review. That is quite the honest truth right now. And B, I don't know if I have the time to do another review. I've got a couple things on deck going on. Probably one of the things I should do today is start the video on the lithium battery. 2 pairs of jeans for 10 pounds, pack of 4 t-shirts for 7 pounds, 6 pairs of underwear for 7 pounds, and 8 pairs of socks for 6 pounds. Nice. You got nowhere to put a 3D printer. Built it from an AliExpress kit, 30 centimeter, 30 centimeter, 34 centimeters, but I had to sell it. Had a big spider on it. Yeah, was it a Tevo? T-E-V-O brand? Because I almost bought a Tevo Tarantula when I bought my first 3D printer, but then this Tronxy X3A came up. Yep, Tevo. Look at that. I knew it. Yep. Almost bought a Tevo Tarantula. I need to, like, at this point, it's becoming obvious I've got so many 3D printers now that I need to sell them, pare them down. The problem the reason why I won't sell 3D printers for the most part is because they're not worth very much. So I really don't want to give me a second here. Quen has I don't know. Maybe this will work. So your 3D printer build was fun. Yes, it was very fun. I would love to build another Voron. Don't get me wrong. The Voron V0 build was a lot of fun. I loved it. But the issue is that right now I can't justify, because I have the Centauri Carbon, I cannot justify buying another printer. And if I do buy another printer, it'll be the Centauri Carbon 2. No, not this Arduino, the other one. So honestly, yeah, again, the whole problem with selling my 3D printers is that I don't think it's worth it. New sketch. Like, what am I gonna do? Am I gonna like spend time trying to sell it for like $100, which is less than what the aluminum extrusions would cost me? Because I'm sure as hell not telling a rando that my 3D printer is a better deal than a Centauri Carbon. There's no way. Boot. Okay, here we go. Now we can upload. And the other thing is, if a rando buys my 3D printer, they might want support. Like, even if you say as is, don't bother me ever again, like, they still have your contact info. So it's not quite that simple. Okay, let's see if Quinn has screwed anything up. Okay, so at the moment, should have no output, which is so far so good. What are we doing again? Oh yeah, we have to power this. So let's grab our power supply. Let's pop it at 5 volts, should be safe. Okay, so it's good it's at 0 right now, which is good. And then pop this onto this one, like so, and then on. So that is definitely not working. That is 100% not working. Okay, is it a problem with the input? Why is it half a volt? Let's check the serial monitor. Video made showing the 47 drones I owned will be dropping at noon. 47 drones. What'd you do for a living to get all this toy money? Fuel, serial monitor. Okay, let's fix this. Ask Quinn for a simple project. This is in relation to RP 2040 and MCP 23017. I want adjacent pins to toggle based on input. Here is the code it spat out, but it isn't functional. Quinn, copy this. Siemens. We have a Siemens office here in Ottawa. It's a RF Tech. Can you post the link? Oh, to your channel. Oh, Franco's got you. Once you get a bit of seniority here, you can become a mod. Radar tech. Do you have schooling to go with that? Like what is your credentials? I would love to go to school. I'd love to be able to afford to go to school. How about that? If I could do YouTube, if YouTube paid me enough that I could go to school full time, that would be incredible. RCC grad. RCC school, Canada. Royal Canadian Christian School, okay. Also known as Royal Canadian College. Vancouver. Oh, Radio College of Canada. Radio College of Canada in Tirana. So do you have what, a bachelor's degree? What's your specific degree? I almost got a criminology degree with a psych minor. Electronics tech. Okay. So electronic technician is a diploma I can go get right now. George Brown College. Let's see, programs. Electronics. DeVry is not in Canada though. Yeah, 1980. Yeah, that's fine. I'm talking about now though. Here we go. 32 weeks. So not that expensive. It's two grand, $2,000. And then here are the courses. But the courses, a lot of them are simple. Like Introduction to Electronics, Current Voltage Resistance, Ohm's Law, Power and Energy, Easy peasy. Series circuits, parallel circuits, series parallel circuits. This is all part of my automotive education. DC measuring instruments do that all the time. $5,200. Network theorems, don't know about it. I have to go look it up. Magnetism, got it. Magnetic circuits, got it. Alternate, yeah. So like most of these, I'm gonna fly right through. And then you can add onto this. Did this work? Then you can add onto this to go further. How do you upgrade this degree? There's a way to increase this. Visiting the Ohio State Fair. Oh, very cool. So you take like, I think it's like 3 more courses. Yeah, I don't know. Anyways, you take a couple more courses and you can upgrade it to a higher degree. But like, it's like 4 more courses, but the cost is like triple. It's insane. Okay. Oh yeah, here you can add the technician, the engineering word, engineering technician. So you have to do 7 courses. So communicating across context, professional communication, technical communications. And then you need an arts and humanities, a science elective, and a social sciences elective. And fuck off. And that costs $3,000. Exactly. How do you upgrade a degree? Add more cash. Exactly. So that is frustrating. But I am thinking of doing this like that. I think I would be able to fly through a lot of this stuff. So like altogether it's gonna be $4,760, like $5,000. But the problem is, to go to university after, it doesn't really change the cost. You still need to go, like you get a Bachelor of Science degree at Athabasca, which, again, so, okay, here, look. So step 1, you do the technician. Then you add the engineering. That's another 3. Then you go to Athabasca University as a second-year equivalent and complete 90 more credits. And then you get a Bachelor of Science degree for $25,000. $25,000. So total is 30 grand. But then you get a this is just a Bachelor of Science. If you want to move this to a engineering degree, oh, this is oh my God, this is such a trade school office. Do you guys see this? The bricks in the background, the generic desk. Wow, this is the environment I taught in. This is so the environment I taught, and he's got the coffee, the Tim Hortons coffee. Oh. Sorry, I had to cough there. This is so the environment I taught in. That is insane. The printed posters on the wall. This is like it's giving me a sense memory. Well, trade schools should probably not be defunded then. I lost my job as a trade school professor because the province removed funding from our program. They stopped funding it. I think Claude is going to choke here. I think I gave it too much effort. I think Claude is going to choke. So anyways, grand total, $30,000. Let's use Gemini. For someone coming from the trades and looking to do engineering and electronics engineering degree from home, I came across this program. It details electronics tech to electronics engineering tech to BSc of Sciences at a cost of roughly $29,000. The question is, with those credentials done, how much would it cost to go to a university and do the courses missing to get an electronics engineering bachelor's? Ontario, Canada. Let's see what it has to say. Get your daily subscriber view count last 2 days because you've edited so many titles. It's possible. They might think your channel is hijacked. Let's see what Gemini says. I probably could have written the code. All right, have a good one, Franco. I'm probably streaming tomorrow if I don't set it to private. Come on, Gemini. Man, Claude is taking up forever. There we go. Look at this. It didn't need to do this. Grokr AI will be doing the design. I think it's the other way around. 2-year electronics engineering technician diploma and general bachelor's of science from Athabasca. If your ultimate goal is electronics engineering bachelor's, the degree required to become a professional engineer in Ontario, taking that specific route is a massive and expensive detour. After finishing the BSc, attending a local university at Carleton or U Ottawa to complete the missing courses would cost an additional $30,000 to $40,000. Take 3 to 3.5 years full-time in-person study. Yeah. If you apply to Ontario Engineering School at BSc, you're evaluated as a second degree or transfer student. You'll get credit for first year math, physics, and complementary electives. What you cannot skip: rigid sequence of engineering design courses, specialized labs, and a final capstone project must be completed at the degree granting institution. Courses are prerequisites for one another. It physically takes a minimum of 3 years to schedule and complete them, regardless of how many transfer credits you hold. Boo! Additionally, there are 0 fully online CEAB accredited PEng programs in Canada. Damn. Technician do not offer bridge pathways 2 years. Technician, they reserve their advanced standing transfer programs for 3 years advanced technology diplomas. The Lakehead University Transfer, the gold standard. Lakehead is famous across Canada for its engineering transfer program. Complete a 3-year advanced diploma in electronics engineering technology at an Ontario college. Attend Lakehead for 2-month summer transition problems, then 2 years. So the problem is I can't do it from home. That's the big deal. That really sucks. Check for copier technician. No, that's not. No, that's not the. It's not about the courses. It's about I want to end up as an engineer. That's the goal here. Did it? At least it didn't even spit out what it. This is the second time. I think I make it think too much. Oh, jeez. It didn't work. I don't think you understood the assignment. I really should have just can I copy this? Copy to clipboard. I really should have just wrote it myself. Oh, I have like tons of mechanical experience. I was a licensed mechanic. Well, still am a licensed mechanic, but for 20 years now. I'm transitioning into tech. So my new job I start in 2 days. Welcome back, ITT. The new job that starts in 2 days is in tech. All right, so let's see if it fixed it. Let's reboot the micro. Let's turn off the power supply. And let's upload this shit. I wouldn't say most of the time it's wrong. It really depends on what model you use and how much context you give it. At this point, I was kind of being cheeky. I didn't give it a lot of context. Okay, so as you can see, the serial monitor is running. So let's see what we got here. All right, so it's still showing a low. Let's turn this on. Okay, maybe it got confused. It got confused. It definitely got confused because now that's high. It's toggling backwards. So that does work. It's just backwards. Let's check the second one. Second pin doesn't work. Oh wait, I forgot it's backwards. So yes, it works. 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 And it works. Perfect. So we're good. So that all functions now. That's tested and working. Let's add that to our notes. Siemens, the big boss, came over to you, Mike Sutton, and told you you're the only person that ever passed 5 tests with 100%. They give technicians applying for a job. That's cool. That's really cool. That is neat. I love it. Let's add this to our notes. Screen. The MCP with input stage and code from Gwen. And although Gwen inverted logic, all GPIO are functional, and there's errata on GPB apparently. MCP 23017 erratum. That's what it's all about. Congratulations. Thank you. What? Congratulations on what? If it works backwards, yeah, it does. Where's the source? Oh, 3D printer finished. Nice. It's a little confused. All right, let that cool a little bit. So which data sheet do we have? So MCP. Is there a revision? Don't see a revision. Oh, this is the old. MCP 23017 data sheet revision D. GPB7 output only. Only 7, not 6 and 7. Okay, so revision D of the datasheet. For the MCP 23017 document states that GPB7 B7 should only be used for an output. So in the final design, bank A will be used for input, bank B for output. Okay. Oh, wait, A7 as well. Uh-oh. And GP A7 used as outputs. Final design. That will be taken into consideration. Oh, was that the PCB? Ah, there we go. Safran was the worst job. They would not let you use a soldering iron. If I found an unsoldered pin, I'd send it to the person back to solder the pin. A few days later, I would get work on it. Wow. Aerospace requires controlled goods certificate in Canada, and the local OLG Shorelines casino was another story. You got fired? Like recently? Got to love when that happens. Oh, I'm sorry to hear you got fired. What'd you get fired for? Like a valid reason, or was it like the something to do with you, or something to do with the company? Okay, good to know. Let's go grab the print off the 3D printer. And then we're probably going to wrap up the stream, so I can go eat something anyways. Grab the little purge line out. Oh, I think the camera's all screwed up. Purge line gone. There we go. All staticky. There's the bottom. Well, I guess I'll just show you on the main camera. Probably easier. Coming back around. Take the long walk from the 3D printer to the bench. Oh, and you guys need to see paint booth fun. Peel the thing off. The finish looks absolutely fabulous. Oh, you work for yourself. So you did you fire yourself, or do you mean like you got fired from a different job that you worked at the same time? I like to grab a little deburring tool, go around any edges. I put in my 2 weeks notice at the repair job because I got the new tech job starting in 2 days. And they're like, yeah, we're going to move that up to today. I'm like, all right, enjoy. Best deburring tools you can get. Yeah, I got a decent one now with a nice like aluminum handle. The problem with Chinesium ones though is they all say they're carbide tipped, but I will guarantee you now they are not. This is definitely just steel, probably high-speed steel. Did I print Danco into the back? No. This is just someone's design from Printables. So there we go. Now we've got 3 stacking trays. And now, because it's a Sunday and electricity is cheaper on Sundays, I will print some inner trays. I just need to pick a different color. I wanted to use up some of this purple, or sorry, not purple, midnight galaxy black, essentially. But I think that'll be it for today. So we're going to call that a day. I will likely be back tomorrow to do another stream, and then there will be no more streams unless they are evening streams until the weekend. at the very least, because I'll be starting my new job in 2 days, and so I won't be here in the morning to stream. So, yeah, we're going to get after it, and then yeah, I need to make documentation for this stage of the input testing, and then yeah, away we go. Thank you everyone for oh yeah, I have extra bits for mine too. I have all of these because I thought I would need more, but I don't. So thank you everyone for being here. Tomorrow morning, very likely going to be streaming, almost for sure. And hopefully I'll catch you then. Yeah, it's a tech job. PCB design engineer for a tech firm. Have a good one, guys. See you tomorrow. Try not to private it.